Hello, everybody. I'm Alex. I am joined here with Zain. He is a member of the Weaviate team, but he's also been a guest contributor for the Semantic Kernel blog, as well as even just a contributor for the Weaviate integration with Semantic Kernel. Weaviate, as he'll talk about, is a vector database that allows you to bring memory into your AI applications. And Semantic Kernel, right, is an AI orchestrator that benefits a lot from having memory and vector databases. So, Zane, do you want to give a quick intro of yourself?
Yeah, for sure. Great to be here. Great to be talking to the Semantic Kernel community. I've been using the tool and I love it so far. So it was interesting to kind of use it, release some of the recipes here. We'll go into that in more detail. But so I'm based out of Toronto. I'm an engineer by training. Then after engineering, I went to graduate school where I learned about machine learning and I got into the data science and ML field from there. And then before joining Weaviate, I was practicing as a data scientist here in Toronto. And I realized that I wanted to do a little bit more talking, more public speaking than I got the opportunity to do in as a data scientist. So then I met up with this team and it's been great so far. I think I've been with the company for about a year now, approximately coming on a year now. Um, and the pace at which things change in this field is so rapid. In graduate school, I was following papers, but like in the large language model space, it seems like you have papers that are coming out every day. There's things to learn every day.
Yeah, I think
And
what's been very cool has been it's not just papers, but it's also code and like
yeah,
open source projects that have come out that allow you to not only read papers, but also tinker, play around with things, and even like build applications on
yeah,
top of it.
I think this is one of the unique things that we're seeing where there's a lot of academic interest, but that academic interest is converting over to industry. Where I think there was a paper that was released from Stanford just last week around creating a virtual environment, a game where there's like 12 agents, 12 large language models that are interacting with each other, and that was a paper. And like days afterwards, a venture capital firm recreated it, open sourced it, and like I've never seen that happen, where you have an academic paper where the industry takes over, recreates it, tries to replicate it, and then you have people that are actually playing around with this technology. It's also the first time that we have this technology from the lab that is ubiquitously available now, right? You and I can use it. So it's the first time my dad knows or my mom knows about this technology. So it's pretty unique time we're living in.
Yeah, I like to call it, it's like your technology has made it when your grandma or whoever can start using it or starts
Yeah.
talking about it. Cool. Well, do you want to talk about maybe high level, what is Weaviate and where does it fit into the AI ecosystem?
So I touched a little bit on this in the intro blog post, and the idea there was now that you have these reasoning engines, these large language models that can perform tasks further up the reasoning stack, right? Like rather than just ask them a question to give me a textbook that's relevant or retrieve a paper that's relevant, I can ask them to read the paper and summarize it for me. We now have an entire developer ecosystem that wants to create apps and but essentially package this reasoning and put it into their application so that they can productize it. And one of the so now you have all these tools that are growing on around this, and Andreessen Horowitz and Sequoia called this the emerging LLM stack. And part of that stack is Weaviate. Weaviate is essentially a vector database. But when I talk to people that don't have a background in vector databases or even data science, really the way that I describe it is imagine all of the files that you have on your computer. You've got audio files, video files, images, text files, you've got emails, everything. How would you search over those files? And typically, how you would do it right now is by looking for metadata. Right? This is a file that was created after the Monday of last week, but before the Thursday of last week, and then you could say, okay, these are the 100 files that I have for those 4 days. But you can't really search over the meaning of those files because up until now we haven't had a database that comprehends the files or the unstructured data in the files. A vector database is exactly that. Right? A vector database stores both the unstructured data, but also the vector representations of that data. So it could be the image, but it stores a vector representation for that image. And then you could ask it, show me all the images with a red door, or show me all the images with running lions, or show me all the images with my son in it. And it understands the query and it retrieves the data that has relevant information. Um, the, that's the that's the functional component of the vector database. And then on the back end, it's just running approximate nearest neighbors really efficiently. So you want to be able to do this over billions of objects in real time. And that's where kind of the engineering prowess of a vector database and the machine learning chops of companies like OpenAI, Cohere, all these companies that are creating the embedding models kind of comes comes towards the intersection, and that's where the vector database lives.
Yeah, I view it as, right, these foundation models, as you said, right, they provide the reasoning engines, but they also are not meant to be, at least today, right, designed to be stateful,
Yeah.
things, right? They are meant to just, you send an API request, you get a response back, but it's not
Mhm.
remembering anything about you. So, and if it does, it's faking it or it's hallucinating it. But yeah, but vector databases like Weaviate come in to provide that persistence, that
Yeah.
preservation and context, right, for
Yeah.
future interactions with these large language models.
Yeah. One way you can think about it is the large language model essentially has a compressed version of all of human knowledge inside of it, inside of the parameters, which is why you've got these models with hundreds of billions of parameters, because that's what it takes to compress all of mankind's knowledge. Um, but it's not so good at it attends to different regions of that knowledge, but it's essentially just a next word predictor that's been trained to behave like a human. It's just been trained to output things that are human like. um, it's not so good at kind of squeezing all of the unique things that happen in the real world. Like if you ask it, how do I fix my car, and it has this type of problem, that is a very niche kind of part of its knowledge that is like distilled in some parameter somewhere. For it to actually retrieve that and then use that to generate, um, you're more likely to get hallucinations because it's just trying to output higher probability tokens. This is where the Weaviate memory is different from the kind of the parametric memory, the memory in the parameters of the model, where now you actually have a search engine over your own data where you can say, okay, search for this relevant stuff. And then you go to the large language model and you say, I've kind of narrowed down the search space of what might be relevant. Now read this, understand it, and then answer the question. Um, it's almost like going to the library and then reading a book about the prompt before you actually answer the prompt, which is a lot more reasonable, rather than saying, recite from heart how you fix the car or this transmission problem in a car.
Yeah, yeah, for sure. Well, without further ado, we'd love to see a example or demo of Weaviate in action with semantic kernel.
Yeah, for sure. Let me pull this up. So first, I'll just talk about this concept of sending the large language model to a library to read relevant things before it has to generate, which is known as retrieval augmented generation, and everybody's been talking about this. Um, I'll talk a little bit about what I'm interested in about RAG, what the next steps of RAG are, I think. Um, so this one implements a very simple RAG. Um, but I think where the field is going, we're going to have multimodal RAG pretty soon, which is what excites me now. But this is pretty straightforward. It's meant to be used as a recipe where let me toggle this so that we have more screen real estate. Um, so here we're getting semantic kernel, which acts as the glue between the all of the different platforms that we're using. So Weaviate being one of them. And as you mentioned, we've integrated Weaviate so that you don't have to learn how the API for Weaviate works and how it's different from the other APIs that Semantic Kernel gives you access to. You only need to know how Semantic Kernel works, and then in the background, you can actually leverage the capabilities of Weaviate. So we're installing all the clients here. Uh, and then here this is very basic. I won't go over this, just setting up the semantic kernel. And then here I'm doing something different where I actually configure Weaviate. Um, and here I've got a local version of Weaviate up and running. There's multiple ways that you can set Weaviate up. Here I'm just locally setting it up. There's also an embedded version. If you're just running a bunch of experiments, you can set up the embedded version. You don't have to set up Docker separately. Um, if you want a long-term solution, you probably want to deploy your own cluster, or you can even do it through Weaviate Cloud Services, and then you get a separate URL that you can pass here. So we set up Weaviate in the background, and then we pass it into to the kernel. So here we instantiate our kernel, so all pretty straightforward stuff. This is where we actually pass in. So this is where we um, let SK know about the existence of Weaviate. So here we're going to pass it in as a memory store. And now I know that you guys have these text memory skills where you usually persist information in the form of text memory. Now you'll be able to use persist memories in the form of documents that are inserted into Weaviate along with their vector representations, and then you can search over them. Um, it's really cool because the syntax is exactly the same. Like you wouldn't know whether you're what type of memory you're querying. So from the end user perspective, you don't need to worry about whether you're using text memory or vector database memory, or maybe tomorrow you have like a graph database or something like that. It's all the same. So this is pretty cool. I like that about this. Um, okay, so this is where we get to the meat of it, right? Why do we want RAG? Um, so first of all, this is a straightforward reason why you want RAG. Okay? If you have just a general query, so if you ask it something specific, it has no information. It'll just hallucinate, or it'll ask you a question. Right? And the reason why it asks me this question is because I've added a little bit of a friendly prompt here. So it's trying to be friendly and it's trying to reciprocate with a question here. You can get it to be more specific and say, if you don't know, just tell me you don't know. You don't have to make stuff up. And then it says, I don't know. Right? And then this is where parametric memory basically fails the large language model. It's trying to search for something that's probable to say, but it can't, and it doesn't know anything else about you. So now you can actually go in and add relevant memories to the Weaviate instance. And so here I'm adding just a class, and then I have a function that adds a unique identifier for every memory that I add. So I'm just generating a bunch of unique IDs, and then I'll add just documents, sentences as memories, right? So unique information. Another useful case of this is if we want to use a large language model as a personal assistant, you could technically you could upsert every email that you're sending out into the vector database, and even you could say, set up a meeting tomorrow at 5 a.m. That would get upserted into the vector database, and then you could search over that vector database through the semantic kernel interface. So here I'm upserting a bunch of information. I specified the class that I want this to be upserted into, and I gave it a reference to the kernel, which is then connected to Weaviate. And then afterwards, when I ask it the same question, right, do I have a pet? Um, so first of all, I can take the result and I can say search Weaviate for whatever's closest to this query, right, to the prompt. So this is the easiest way that you can do uh, retrieval augmented generation in. So in this blog, I go over this, so I can go through the flow chart here. So if you scroll to the bottom here, so essentially what you're doing is here, you're taking the query, and rather than just calling an API and passing it to the large language model, you pass it to the vector database and you find whatever is relevant, which in this case happens to be this one memory that I passed in here. So there was a reference to a pet here. And even though the word pet is not in here, it knows that goldfish are pets. And this is where the semantic search, the fact that your database understands what your data is, rather than just doing keyword matching, comes into play. And this is good for natural language, but this also works for images. Right? So technically, you could query, and if you have images of pets, it would pull up those images as well. And this is where I'm really excited about the multimodal components of RAG, where you could pass in an image and you could say, okay, generate a poem for this image or using this image, and you could pass in audio and all sorts of interesting things. I've actually got an interesting demo around that. Maybe if we have time, I'll show that as well, where we've integrated multimodal models so that you can use those with Weaviate, and you can literally query with the, the sound of you speaking or a song, and create like a Shazam type of app where you can say, "This is a tune that I've got stuck in my head. I can't remember what song it's from. Play that tune,"
Mm-hmm.
and then your if you've got a database of songs, the relevant song comes back. Um,
Yeah, I would love to see that demo.
yeah, for sure. Um, okay, so we've got all these memories in there. Um, so the relevant thing here is that not only to get whatever's important that comes back. So if I query with the word passion, the one memory that is relevant here is the fact that I love data science, and it comes back. You can ask it how relevant this is, and this depends on the metric that was used to instantiate the vector database. If there's a dot product or cosine distance, this will change as a result of that. But you can use this as a proxy of how similar the result is versus how different the result is. So you can even do thresholding to say, if you ask for a concept. So here I've only got 3 memories in my database, right? So it's a toy example. If I ask for, I don't know, something related to food, there's nothing related to food here, but it'll still give me back relevant results. And I can then threshold it and say, if it's not higher than zero point 0.8 relevancy, then just don't give me anything back. So this is one way that you can use this. So now that we have the database set up, now we can actually, so this took a little bit of prompt engineering to get working. In the beginning, I just said, answer this question, here's relevant information, and it doesn't work as well, because then it always conditions on the information that you give it. So you have to be a little smart about how you get it to conditionally use the context you give it. So here I'm saying, here's information that I've provided. It may be useful, it might not be useful. Use it if you need to, and if you don't know, then you just say I don't know. And this, depending on your application, if you're using this recipe, this is the one thing that you want to modify to fit to your particular chatbot. You can get it to uh, do anything pretty much with this. And then here I've just set up the rag function where I create the function, and then I set up the context that's going to that the kernel will have access to. And then I just set up the rag instance where I go through, and I was trying a bunch of things where in this one I just wanted to do one retrieval. Right? So I go in, I search my vector database for relevant concepts, and then I retrieve the most relevant concept. So I only retrieve one memory, and then I pass that into that's going to be passed into the context variables over here in the form of retrieved context, and then I generate an answer using this information. And the prompt here knows what to do with this retrieved context. This is the variable that I refer to later on. So if you want your large language model to generate well, the easiest thing you can do is kind of tinker around with the prompt here to deal with information as you want it to. And then you have just kind of one prompt, one retrieval, one question. So this entire workflow is replicated over here. You have part one, you query, you get the relevant information back, you stuff that into the context, and then you generate a customized response as a function of this. Um, Going from this to the chatbot is pretty straightforward. All you want to do is um, keep on keep the loop up where it keeps on questioning you, and it has its own parametric memory of everything that you've talked about in the chat, and you've got this augmented memory of extra information that you can now source. This is the other cool thing that I chose to do. Not only is it going to answer based on information you gave it, but it'll also cite the sources. And this is one of the things that I think Microsoft also introduced, right? When ChatGPT came out, people were able to converse with it, but you couldn't tell when it was hallucinating or not. And then when it was integrated into Bing, it actually gave you the answer. And then there were sources at the bottom that I really liked, and that's one of the things that vector databases also enable. It'll tell you, why did I answer the way that I did, and whether or not the context that you gave me was relevant or not. Um, and this goes a long way in terms of interpretability of why it's doing what it's doing. You can even tell whether it's hallucinating or not based on information that you gave it. This is factual, and if it's telling me something weird here, then I know something wrong is going on, right? Because I get the best of both worlds now, where I can have the source material, and then I can see a nicer version of the source material up here that the large language model generated, which is, I think, the best part that I like about RAG. There's a lot of kind of advantages of RAG, but I think this is this is what wins it for me, right? The fact that you have sources and then you can identify hallucinations as a result of it right there on the spot.
Yeah, for sure. I mean, this is very cool, and the RAG pattern has become the industry norm for this sort of things.